We are talking about Pythagorean theorem, and we want to use the Pythagorean theorem. So here we have some word problems, and we have two trains left Charlotte at the same time. One traveled south at 50 miles per hour, and the other traveled west at 40 miles per hour. How far apart were the trains at the end of 3 hours? So, first of all, we have to kind of understand what's happening in the situation. So, be good idea to maybe even draw a north arrow. So we got north is this way. So this way is north. Then we have east, south, and west. And so train leaves from Charlotte heading south. So we're going to put Charlotte as this black dot right here, and that's Charlotte. And we have a train that heads directly south. And then we have a train that heads directly west. Now, this isn't probably quite 90 degrees, but it's supposed to be 90 degrees. So one train traveled south at 50 miles per hour. So it's heading this way at 50 miles per hour. And the other train traveled west at 40 miles per hour. How far apart were the trains at the end of 3 hours? So what we want to do is we want to multiply both of these by 3 to get the total distance they've traveled. So 3 times 40, that means that this one traveled 120 miles. And 50 times 3 means that this one traveled 150 miles. And now we want to find how far apart the trains were. So how far apart the trains are has to do with the straight line distance between them. And that will be that distance right there, which we will represent with x because we're not sure what that one is. So we have a right triangle. The side opposite the 90 degrees is the hypotenuse. And so we can set up our Pythagorean theorem. And we can check if x squared, well, it is equal to, because we said that's 90 degrees. So x squared is equal to 150 squared plus 120 squared. And we can use our calculator for that. On the left-hand side, we still get x squared. On the right-hand side, we get 22,500. And we get 14,400. Then we can add those together. On the left side, we get x squared. On the right side, we get 36,900. And we add these two together. Then we can go back and think about GEMDAs. And remember, when we're solving, which this last step is solving, we want to start with addition and subtraction. which we don't have. Move to addition or multiplication division, which we don't have. And then we get to the exponents. And the inverse operation of x squared is the square root, because the square root cancels the square. And we got to take the square root of this value as well, 36,900. So we turn on a calculator, and we want to hit the second square root, 36,900. And we get 192 and some decimals there. So x is approximately equal to, that's the approximate sign. It's kind of like an equal sign with a wave there, and that's going to be 192.1 miles as we round it. So that's how far the two trains are apart. Next example that we have is we want to find the height of the isosceles trapezoid. Find the height of the isosceles trapezoid whose sides have lengths of 12, 14, 12, and 34. And we want to find the height. So the first thing is we want to draw the isosceles trapezoid. And the isosceles trapezoid means that the two sides, the two legs are congruent. So we have one short side, and then we have one long side, and then our two legs are supposed to be drawn congruent. They may not be exactly congruent, but the intention was that they are congruent, because the value that we were given is 12 and 12 for each leg, and then we had 14 and 34 for the two bases. Now the height of the trapezoid is going to be the distance that goes that is perpendicular to both bases and touches both bases. And I'm just going to happen to draw it on this side over here. So this is a right triangle. We can see that. And this is the triangle right here that we're talking about. Shade it in just a little bit. And we only know one side. We know the hypotenuse. The question is asking us if we can get this height here. That's what we're trying to find. But we need to know the distance. We need to know the distance from here to there. Now, that distance is going to be the same distance as on this side right here. So we need to be able to calculate that distance. So because this is an isosceles trapezoid, this value right here is the same as this value right here. So those are both y. And then remember, the whole length of the base of trapezoid is 34. So we know this is y, we know this is y, because those have to be congruent. The whole thing is 34, but we need to know the distance from this corner right here to there, because then we'll be able to say y plus this value plus y is equal to 34. Well, this distance right here is 14, because y 14y is equal to 34. So we can set that up. So 34 is equal to, in this value right here, y plus 14 plus y. So we can combine our like terms. We have y and y, that becomes 2y, and that's still going to be equal to 34 plus 14. And now we're using GEMDES again, and we want to start with addition and subtraction and work our way to groups. So we can subtract 14 from both sides of the equation. Our 14s cancel, and we're left with 20 is equal to 2y. Then we can divide both sides by 2, because the next thing in the list is multiplication, and the inverse of multiplication is division. So our 2's cancel, and then we're left with 10 is equal to y. So now we know our y value right here is equal to 10. So we have two sides of a right triangle. We have a leg, and then we have the hypotenuse. So the Pythagorean theorem says c squared is equal to the sum of the square of the other two sides. So that's going to be a squared plus b squared. And now we can substitute our values in. So c squared is going to be 12 squared, and that is going to be equal to our x value squared plus 10 squared. So we can do this math, and 12 squared is 144, and that's going to be equal to x squared plus 100. Now we're back to GEMDES again, and so first thing is addition and subtraction. Inverse operation of addition is subtraction, so we're going to subtract 10. Sorry, that's 100. 10 squared is 100, so we're going to subtract 100. The 100s cancel, and we're left with 44 is equal to x squared. And then we want to solve this to get x by itself. So we did addition, subtraction, we did multiplication and division. No, we didn't. There wasn't any multiplication and division. So now we're on to exponents. So now we can take the square root of both sides, and we can plug that in our calculator, and we get 6.63 is approximately equal to x. So the answer for this question is the height of the trapezoid is about 6.63 meters.